Okay, no power. No. Okay. Okay, so first, before starting, a quick update on the course schedule. Actually, I updated this morning the course schedule till the end of the course. Okay, so it means now, today, we are here. Okay, and we still have a few weeks. So the next one was already there. We still have 2 more weeks. Okay, so still 3 labs. Okay, and you remember that for the first exam, the text of the first exam will be published actually 1 week before the course ends. Okay, so around July the 2nd, where we will not have a lecture, I remind you, because it's a national holiday, right? So, but we will use the other slots as usual. Okay, and then after the course is finished, actually for the second exam, there will be the text for the second exam on Monday, June 16th. Okay, just 3 weeks before each exam date. Okay, and the same will happen for all the other exams. So for the exam in September, for the exam in whatever it is, January or February, depending on which date they will choose. I will not choose. I don't choose the date. I mean, they means the university administration. I mean, having a schedule which fits for everybody, choose the date. Okay, so we have actually no control on those dates, unfortunately. Okay, so this is just to give you an overview of what we are going to do until the end of the course. Unless something happens, you never know, but I mean, if nothing unexpected happens, this is the plan. Okay, so today we are going to talk about CORS that we just briefly mentioned on Monday, and you actually used it. I mean, it's very simple to use in the simplest form in the lab, and now we will discuss it a bit more because it's important. I mean, it has a lot of implications, why it works that way, and so on. Okay, and then we will continue with the slides we already have. So the useEffect, we will finish the discussion, and we will try to implement what is needed for the next lab. So actually, I think this is not refreshed, right? Yeah. Let me refresh the page. Or maybe I didn't push it. Anyway, yes, okay, now it's update. The add, the update and delete operations, okay, that you will implement in the next lab on next Tuesday, okay? And then we still have one big topic, which is authentication, which is really important. Of course, you're from the course of study of cybersecurity, so it's really important to understand these things very well, okay? And this will take us till the end. And actually, I remind you, the last lecture, 5th of June, we will try to solve an exam together. Actually, I will solve it. I mean, trying to design the solution. We will not have time to implement everything, but I will provide you the solution afterwards, okay, offline on the GitHub website. And but I mean, it's meant to be a discussion. I will propose something, but if you think things should be done differently, and you have a reason, or you have no reason, or you have no idea, you can ask why, and why we shouldn't do this way, and so on. Okay? Because in this way, we have all the elements, and we try to use them, you know, for designing actually the solution of an exam. That is what you need to pass the exam, of course. Okay, so let's go back to the slides. And we discuss first CORS. It will not take that much, maybe an hour or something like this, but it's important to understand the problem, okay? So, actually we start from the history, okay? Well, you know that when web was born, actually it was meant to load many different types of resources. Of course, HTML pages, so content, text, and so on. But also, since the beginning, also images, and when they arrived, also CSS, so styling systems, code, and so on. Okay? So actually, you know that nowadays in HTML you can write img with a URL. Whatever URL you put there, the browser will load the image. Okay? It is not restricted to be from the same website where you started. Okay? Because this is the way in which the way worked actually when it was born, 1991, I think. Okay? So, loading resources from different web servers without any limitation, indeed, was a normal behavior in the really old days of the internet, and we are talking about more than 30 years ago. Okay? But nobody at that time envisaged what the web was going to be. Okay? So, a system to design and to run actual applications. Okay? Which is very different from just accessing documents, browsing documents and images inside the documents and having links between documents, and that's all. That is how it started. Okay? And nowadays, browsers can also keep more than one web page open at the same time. Computers are so powerful that you can have different websites, and means different web applications, running web applications open at the same time. This is what was not common, and actually was not actually possible in the old days of the internet and the web. Okay? And so nowadays we have a problem, a security problem. How do we keep things private in each browser window? I mean, I have my bank account open in a window, I have my Google account with the email open in another one, I have a third unknown website, web application open in a third window, and so on. Okay? And everything is running in the same program in the web browser. So, and this is really problematic, especially when you have authenticated section active. It means that in your web application for the bank, you logged in, and so you can perform operations. You can browse, the current account, amount and stuff, or whatever. You can buy things on Amazon and so on, okay? Because you are logged in. We will talk about what logged in means next week, but I mean, you know what it is because everybody uses it every day. Okay, so this is the security risk that we are incurring into. So we are actually risking that something like this happens. So we basically open a website, any website, which I mean, we don't trust that much, but we need to use it for some reason. We browse the web at some certain point. We want to use it, visit a certain website. And so there's an initial web server that serves an HTML page. And this HTML page, as any HTML page since the beginning of internet, can refer to any other resource on any other web server around the world connected to the internet. Okay? Like for instance, you see this tag img. I mean, I'm taking the img tag because it's one of the first tags that was available in the internet, and that's why it still today allows you to load stuff from anywhere in the internet, because that was the behavior in the beginning of the internet. And you can put any URL, okay, inside the src attribute of img that basically tells the tag where to load information from. Okay, any URL. And so what happens in case some malicious website, okay, do something like this, like it references some other website outside its domain, okay? So like, some places where the attacker wants to steal information, okay? Or wants to perform operations that is not allowed to do, and so on. Okay, so let's take this bank.com example, just because banks involve money and it's nice to show in example, but can be anything, and can be Amazon, can be whatever website you need authentication for using it. Okay, and what happens is that this request for loading this resource will be sent automatically by the browser. We cannot do anything about it because that is the default browser behavior even nowadays. Why? Because we don't want to break all the websites. All websites works expecting that any URL in certain tags, like the older tags like img, script, and so on, work regardless of the host name that you put there, okay? And when you do a request towards a website where you previously authenticated, actually the authentication information in the form of cookie, and we will discuss them more in next week, but you should already know something from networking courses and HTTP. And so these cookies are sent in any case automatically by the browser. We cannot do anything about this, okay? Again, this is standard behavior also for browsers, today's browsers. And so the bank.com web server will receive this request and will send back a response, okay? And the problem is that now we have a response, okay, where we loaded some information, and actually the information is loaded in a place where it can be accessed by JavaScript or other system like through the DOM, JavaScript plus DOM, inside the context of the first web server where we loaded the first web page, okay? And so basically the JavaScript inside this first web page, inside the window that loaded this tricky.com page, which is the one from the attacker, which is actually unknown to the actual user, risk exposing information to the JavaScript that should not be exposed, okay? And the JavaScript then can do anything with this information. Like you know, we have the fetch. Fetch allows you to do any request towards any websites around the world, okay? So it can send information through a get, through a post, and so on. Get with the URL and post with the body and so on, okay? So actually, this is the point that we should try to address nowadays, keeping in mind that we cannot simply say, well, we don't want URL that points outside the page of the initial web request, because it will break a lot of websites, all the websites actually, but I mean, still will break a lot of websites. So, so how do we address a situation like this? Well, actually, I mean, the only way to address it nowadays without breaking the old web, means the old web pages and so on, is not allowing JavaScript and other systems to access information coming from other web servers, say it in short, okay? Because actually the browser must load the image and must show the image as well, if it is an image. Of course, if something wrong, it will not show anything, okay? Like in this case, if we access something which is not an image, it will appear as a broken image. But I mean, the attacker doesn't really care. The attacker cares about only capturing the information, okay? So even if the image is not shown, because actually the data retrieval is not an image, this is not a restriction for the attacker, because then it can use like JavaScript or something like this to access the information and send it somewhere else where it can be further used, okay? So a third website controlled by the attacker, or even at the same website. So actually, nowadays, browsers do not allow the DOM and JavaScript to access data and cookies coming from servers which are not the original one, okay? The initial ones. Because of this security risk, okay? So they still need to load the information, so they send a request, they get a response, and if everything is fine, they'll even show the response, okay? They even run the JavaScript code, but they don't allow to access the content retrieved from different websites. We will be more specific in a minute, okay? Why? To avoid that data, private data, is stolen, okay? As we saw before, okay? Because we have this two, let's say, sort of behavior. I don't want to call them problems. Actually, the browser needs to load the information, and the browser, if the session is authenticated, so there's a cookie associated with that web server, it will send the cookie as well. So the web server has no way to tell that is a request that doesn't come I mean, it's not authenticated. It actually comes with the authentication information that is the cookie, and so it responds. So in practice, nowadays, browsers, I mean, from a certain number of years, browsers implement the so-called same origin policy, SOP. So it means that content and data coming from different origins can be loaded, but cannot be accessed freely by the page. Okay, the page is just one, is the one that you loaded from the first web server. Actually, this is really, something that was introduced quite early. I mean, I would say quite a few years ago, 30 years ago. Actually, one of the first programs, maybe you never heard about this, but anyway, there was a company called Netscape that developed one of the first browsers, was called the Navigator. And actually, version 2 introduced JavaScript, and so actually in version 2.02 they realized there was this problem. So they made a patch, and actually the patch was actually implement this behavior of the same origin policy. So preventing, I mean, I don't want to break everything. So I load the stuff, I show the stuff if it's needed, if it's requested, but I don't want the code and the DOM in the page be able to access something that has been loaded from a website which is not the one from which I started. Okay? Actually, it's a bit more specific. It's an origin, not really a web server. So what is an origin? An origin consists of a URI scheme. Actually, nowadays, it's either HTTP or HTTPS. Domain, so the usual domain that we are used to see, okay? And the port number, okay, the port number, the TCP port number. And so the rest of the URL is simply ignored, okay? So let's make some examples. An origin is URI plus domain plus port. And to be the same, all three must be the same, okay? So consider that if we start loading this URL, http website.com with some internal URL, okay? And so if you go to website.com/something else, yeah, actually, yes, it's the same origin because same schema, same domain, and same port. Sometimes the port is implicit, okay? So HTTP corresponds to a certain port, 80, and HTTPS 443. You can make the port explicit, like we do with our examples, 5173, 3001, and so on. Otherwise, there's an implicit port. The default port for HTTP is 80, and the other is 443. Okay, so site 2 and so on, okay, same scheme, same domain, same port. HTTPS, that's not the same origin, okay, because it's a different scheme. And also, actually, the port is different as well, okay? It's just implicit. HTTP and dot something, so the part of the host name, I mean the domain changes, well actually it's a different domain, okay, from the point of view of the same origin policy. So you cannot just have subdomains, okay, it just needs to be exactly the same. And of course if the port changes as well, okay. So in short, you really need to have the same scheme, domain and port so that what you load is accessible from the DOM and the JavaScript in the page, okay? So actually, we managed in some ways to solve the situation coming to a point like this, okay? So initial web server serves a page, and then we have tags like, I mean, these three tags, IMG, link, and script, which are the most problematic because they are the oldest one we don't want to break, okay? So we need to load the content, but then these are the ones that are going to be restricted. So we can load stuff, show stuff in terms of images, like CSS content and so on, use it, have the browser use it, even scripts, okay? But we cannot access them from the JavaScript loaded in the initial web server page, okay? So actually resources are rendered, incorporated in the page, used as they need to be used, but cannot be accessed by the DOM and JavaScript from the initial page, okay? But what happens if we actually need to do this operation, okay? Because sometimes, just for convenience, content and services are split on multiple web servers, especially nowadays when things are very complex. Okay, so like we have in the lab now we have an API server plus a server, the initial server that serves us the page. But this is very common in complex web applications. Okay, not just an issue of our lab. That's why I want to explain this thing, because there are ways to to solve the problem without all this long explanation. But since it's very common, we need to understand why it happens and why what we should do about this, in terms of especially of configure it properly with the security in mind. Okay, so how can we handle the cross-origin situation? So we have more than one server, which is actually a different origin. So it's not just a different path, but there's something different, something more which is different. Well, option number one, of course, is really limiting. I mean, don't use it. I mean, not really a solution. Okay. Option number two is find a mechanism, and we will see it now, to allow some cross-origin data access in a controlled fashion. Okay, so in a way which is controlled by the servers and the application. Okay, and this is really important because it allows us to use any other server, in particular third-party API servers. Like, let's say you want to incorporate, let's say, some data that comes from a third-party web server that you don't control, like weather forecast, like a stock, the price of the stock market and so on. It's typically on a different website and a different web server, and you don't control it. Okay, but maybe you want to show it. I mean, showing it easy, but you want to access it and manipulate the information coming from those servers, because for some reason you need to process it in your website. And so we want a controlled way to perform this operation. And so we come to this CORS, okay, cross-origin request sharing. Okay, so this is actually a standard mechanism to handle cross-domain, I would say, cross-origin requests. Okay, and how it works? CORS defines a set of HTTP headers. In particular, there are two main headers, that allow the browser and the server to communicate and decide if the request, so for each request, if the request is safe to be accessed by the DOM and the JavaScript in the initial web page. Okay? And actually, it is the server that defines which origins are safe, so which initial web pages are safe. Okay? Web servers and web pages, so hosts in short, actually origins. Okay, so in practice, so we start from the browser. Browser loads first website because somebody has put the link on the URL bar, or you clicked on a link you want to access a page on some web server like bank.com, like google.com, and so on. The browser knows that it loaded the first page from this host name, like bank.com, site.com here in this example. Okay, and then when it needs to issue a request because of something that it found in the HTML to another origin, it knows it's another origin. It's very easy to see it's another origin. Just compare scheme, domain, and port, right? And when the browser needs to send requests to other origins, it includes a specific HTTP header inside the request. Okay? You know what headers are? That's not mine, right? Headers are stuff that comes after the first method, right? Okay. The first method says get, post, put, and so on. Everything fine. Get, post, put, and so on with the URL, and then you have HTTP headers. Okay, like there's a mandatory header in HTTP 1.1 host colon with the name of the host, and other headers, like we saw the content type, for instance, when we talked about communication between client and server. Content type application JSON. This is another one. Origin, colon, with the name of the origin, complete name, okay? Scheme, domain, and port. And the response. The response from the receiving server includes another header, which is named a bit longer, access control allow origin, okay? And it says, which origins are allowed to access the content provided by the other server, like API.com in this example, okay? If the two match, or in general, if this one can be also a specification, multiple websites and so on. So if the origin is included in what is allowed, the browser allows the DOM and the JavaScript to access the response. Otherwise, what does the browser do? Actually, it will appear for the JavaScript and so on as failed to load, okay? Even though the browser was able to load it, okay? Because actually you cannot just say, well, it doesn't exist, okay? Yeah, actually it failed to load, so I don't give you access to, okay? So everything that goes to a different origin, it's a CORS request, so a cross-origin request, and yes, actually just a way for sharing, so actually allowing the code in the first page to access what is returned from another server. Remember, this is just a browser mechanism, okay? So it's not about making sure that nobody can access to the second server if not authorized, okay? Because this must be handled by the server itself. That's the only place where you can authorize people to access information. So authorization to access information is something different from CORS, okay? CORS is just using the information in a certain web server in a certain web page inside the first page that you load in the browser, okay? Just to avoid users being tricked by malicious websites, actually, okay? So if you issue a request outside the browser, you can set the origin to whatever you want. Outside the browser, you control everything. You implement the HTTP protocol, so any program can set the headers it wants. Okay, so like curl, wget, REST client, whatever. You can set whatever header you like. So it's not about an access control mechanism for something outside the browser. It's just for within the browser. Okay. By the way, for server receiving the request, if no origin is set, origin is considered equal to null. Okay? So in short, they don't match anything. Okay? So the web server, remember, must rely on proper security mechanisms to authorize data access. Typically, there has to be a session already established, or maybe you need to send a token or something that has been signed and so on. Some mechanism, some secret information that needs to be sent in the headers with the request to access the private protected information. Okay? And the origin is just the other way. So allow the page that started the request to access the information inside the browser. Okay? Okay, so now we are almost done in the sense that, this access control allow origins works, but what if I need to send a request that includes private information from the first page? Okay. Well, actually, I don't know the response. No, it's not. I don't know what is doing this noise. But anyway, I don't know the response of the second server until I send a request, I get a response, because the access control allow origin header comes from the server, right? And so that's sort of deadlock. I cannot send a request because it includes private information. But if I don't get the response, I don't know the value of this access control allow origin header. Okay? I don't know what is making this sound. Anyway, let's hope it's nothing serious. Okay. And so actually, to make all the core system work, they invented this pre-flight request. So basically, automatically, without us doing anything, the browser sends a request, empty request, where in short it uses a special HTTP method which is called option, okay, that basically does nothing on the server except querying the server for headers, okay, and it sends the request with the same origin. So it sends the origin, and the server recognizes this request, and it answers with this header with all the origins that are allowed. And so the browser knows if the actual request with the private information and sensitive information can be sent. So the actual post, put, and so on. Okay? Typically, get are not problematic, but post, put, and so on. That's a list if you go on the websites, on the documentation, what is allowed, what is not. Anyway, this happens automatically through the browser. I mean, we don't have to configure anything. Okay? We just need to know that this happens because basically for every request we are doing, actually 2 HTTP exchanges take place. Okay? And we will see them. If you open the network tab in the inspector of the browser, you will see the double request. You will see the pre-flight with the option, and the second one with the actual request, the actual answer. Okay? And so such cross-site requests, where you need to send the information, the request twice, are said to be pre-flighted. Okay? So pre-flight means you fly before and you ask if it's possible, and then you send the actual request. Okay? So performed automatically, we just need to know they exist. Okay? Example, so the browser does options with a certain URL. Okay? Access control request method, so there are additional headers because it says I want to send a post request, and the server responds, okay, this is the origin which is allowed, and these are the allowed methods. Okay? So that's how it works. But I mean, basically it's everything that's been made automatically, at least on the browser side. We don't touch the browser, it's already implemented. We need to configure a little bit of things on the server side. Okay? Especially when authentication and so let's say important information is involved. Okay? Actually, browsers typically do not send credentials like cookies, which are really important for us for authentication, in cross-origin requests, but actually we can force the browser to do that. Actually, in our applications, we will do it interaction with the server only with one primitive of the server, which is actually the fetch method. Okay? And so, you know that we can pass an object. Not sure if we discussed it before, but well, anyway, as a second option, we can pass an object to the fetch that can include the method you want to use to contact the server, and second, yes, we did it, I think, with the content type. Okay? To set the content type, we can also set another option of the fetch. So this goes to the fetch. Okay? That then it forms the HTTP request, which can assume different values, and the important one for us is include. It means including the cookie. Okay? even if it's a cross-origin request, okay? So we just need to remember this at a certain point, and actually next week I will remember you when we start talking about authentication. And then we will see what happens on the website, on the web server in a minute, okay? Just a few more words about the scripts, okay? Actually, we already loaded scripts from other origins. You know, from the beginning of this course, I told you, well, let's use Bootstrap. It is so nice. It's so good for styling websites. Oh, that's a CDN. So actually another web server. And it's so convenient to load the stuff from that place, okay? Now with Vite, we bundled everything together. But before Vite, you had to manually add the script tag, and you can put any URL you want in the script. And indeed, it worked, right? We didn't have any problem, no CORS problems and so on. Just needed a network connection. We were able to load a day.js library, so some day.js code from the network and so on, okay? So actually, why? Because that's the way in which all the web browsers worked. And if we don't allow loading those scripts and running those scripts, we will break a lot of old websites, okay? And we don't want to do that. But nowadays, if we care about security, as you should in the course of study of cybersecurity, just make sure you only load code you trust, because when you load some code, okay, you need to load the code. I mean, the loaded code actually runs in the same space as your own code. So it has access to all the variables, all the stuff that you have available in your JavaScript running environment, okay, runtime environment. And so make sure you only load the scripts, so code you trust, and also use the integrity attribute, because I hope that you checked the code. And so there's a specific version of the code that you trust, okay? And you should enforce the browser checking that is actually the same version that you checked that is being loaded and executed, okay? How do you do this? Well, actually, we already saw it, okay? You specify an integrity attribute, which is actually an hash of what you are going to load. The browser loads the resource, then computes the hash, and then it compares to the hash that is actually being served from the first website, because this is part of the HTML code that you loaded from the first website, okay, the initial one. The only thing you need to be aware of, and now you know why, is that, again, not to break the old websites and the old web and so on. To make the integrity work, you need to specify this additional attribute that we already saw, but I didn't explain. Cross-origin equal to anonymous. So this is an anonymous cross-origin in the sense that basically we are not sending any private information. And actually, to make everything work, the server has to respond with actually this header, the access control allow origin. And since it doesn't know which is the origin, and it cannot configure an origin for each one of the sites that are going to ask the same content, like think about Bootstrap, anybody using that, okay? It can write a special character, the star, which is typically the one that says anything, okay? So basically, any origin is fine. Because we are not providing any, not receiving any private information, and we don't really care where it is used, okay? We're not bank.com, which actually really care where the information is used, but actually, I mean, anybody can use the information. And so the CDN actually is configured to send back this header. Otherwise, the browser wouldn't work if you put the integrity plus cross-origin attributes, okay? You can check this stuff. I mean, just to make an experiment, write a simple HTML or take the ones from the old labs and have a look at the network tab. You will see these headers. The origin header in the request and the allow origin header in the response with the star, okay? Okay, so make sure that every time you load external scripts, you have some hash or integrity to be checked by the browser. And make sure the browser checks it, okay? This doesn't apply if the result comes from your website, okay? Actually, with Vite, everything is bundled together, so actually we don't really care about this. That's why we don't put an integrity and so on. Because if stuff comes from our website, of course the browser has to trust it, because it started from that website. If it doesn't trust, I mean, just go to another website. Don't open it, okay? But so everything comes from the same origin, is by default trusted. Stuff that comes from other origins is not trusted, and we need a mechanism to say it's trusted, okay? Okay, also loading modules through the script tag. Well, actually, all modules loaded from the script tag, so with the type equal to module attribute, are subject to the CORS rules, okay? Why? Because this doesn't break the old web, because the modules didn't exist in the beginning, okay? And so we can safely introduce this feature. And that is why, when we experimented in the beginning of this course with this script tag, actually we didn't use modules, because to use modules, actually you need to have a server that responds with that header, and you cannot just simply load a file from the file system, which is much more convenient for testing, okay? Anyway, this is just a detail. I mean, because at the moment, I mean, from now on, we are just caring about our React application, and our React application is bundled together in a way which works with these peculiarities. It's a module, it's fine, but we are serving it from the internal web server of Vite, and so everything has been taken care of. Okay, so everything works, and we don't really need to care, but we need to know at least. Okay, so let's come to the last part, of course. How do we configure the server? Because we said we need to send that header, and that's why in the lab on Tuesday you had to do this operation, which is the simplest one we can do. Actually, okay, require CORS means just load the package that introduces this header, and just tell Express to use this one, which is actually the middleware. So something that is put together between the request and the response, and it takes care of inserting the header in the response before sending the content, okay? Just be careful, because this way of writing CORS enables all origins, okay? So it was fine for the first lab, but we will have to refine it also for the exam, because we will need to send cookies and so on, so this will not work anymore. So enabling CORS for all requests is very simple. Actually, just you do app use CORS, okay? But in this way, all origins for all HTTP methods are allowed, so not really helpful if we need to restrict something. I mean, the good thing about enabling it at the app, means Express level as a middleware, is that it automatically also handles the pre-flight requests for all routes. We don't have to specify anything for the single route, okay? Who takes care of responding to the option method of HTTP? Actually, it's CORS. We don't have to write app.option and decide what to respond. CORS will do it for us, okay? We can also use it as any middleware on single routes, but I don't recommend you to do this. Just use a global configuration, and when we will have to use credentials, means the cookies, we will have another configuration. Just be aware of the fact that CORS, I mean, we used it with the empty brackets. It can take an object that configures the CORS, actually. This is the configuration method, which is actually, the star that we saw before. Anything is allowed, okay? Any method is allowed, so the list is complete. And, well, other details that we don't really care of, okay? When we will have to send cookies and other credential informations, we will not be able to write a star. I mean, it's really kind of stupid put star if you receive credential. It means that anything can use this credential. So actually, CORS was invented to prevent this condition. Okay, so it's fine in case. I mean, we don't have really sensitive information like bootstrap stuff. I mean, anybody can use it. We don't really care. I mean, it's there to be used from anybody. But if we reply with private information, actually, we would like to restrict the origin to something more restrictive. I mean, not really everybody. Okay. So in our case, it will be HTTP localhost 5173. Okay, because Vite runs on that origin, from that origin. And we also need to put this credential true, okay, just to make sure that CORS puts answer with the correct headers back, okay? But I will remind you later in the course. I mean, when we will do the example with the cookies and so on, we will go to the server and make a modification, okay? So this is the condition. Actually, it's exactly the same as before, but now it's more specific of our case. Localhost 5173 is the initial server. You know that when we open the application, as we will do today as well, we put localhost 5173. That's the first website we load, so that's the origin. And then we make cross-origin requests to another server, which is localhost, and we typically use this 3001. Okay? Through fetch, it's fine. Fetch is subject to the CORS rules as well, of course. Fetch was introduced much later, so we don't break anything if we make fetch subject to the CORS rules, and that is good. Okay? So I hope everything is clear. There are a few references in case you are more curious. I mean, you are curious about these things. I mean, like on OWASP, there's a lot of discussions and so on. You can have a look at the code of the CORS module as well. Okay, and so I hope you now know why we need to specify this CORS on the server as we did in the lab on Tuesday. Okay, and I want to keep it because actually it's a situation that is encountered a lot around I mean the internet when you have a complex web application. Okay, the simplest thing would be take this server and hide it behind the initial server. I mean, with a proxy, with some stuff like this. So actually, everything is served from the same server, okay? And you need only to trust what is behind the server. That's another option. But I didn't want to use this option because we are in the cybersecurity course of studies. Better we understand what's going on, okay? And why this course issue exists and how we can solve it. Okay, handle actually. I mean, don't want to really solve it. Just handle in the correct way. Okay. Okay, good. So let's resume with our discussion about talking with the server. Now we know we have this API server, and in the API server, yeah, we started to handle some API calls that comes from the client. And actually, you already tried in the lab to retrieve some initial information from the backend, which is actually the application state, the list of fields. In our case, the list of the answers, and so on. Okay? So basically, what we need to show in terms of data in our application is typically the state. Plus some other state, but typically these states are not loaded. I mean, just the presentation state, like we are waiting for loading to happen or not, okay? Or something is open or closed, or the local states of the forums and so on. These are local states, okay? And we don't exchange them with the server, okay? Okay, but we need to perform many other operations with the backend. I mean, all these CRUD operations, create, read, update, delete, okay? Not just about reading. I mean, showing information is easy. We need to be able to create new elements, update, delete, and so on, okay? And also, we should periodically check for updates, and now we will discuss a bit more on this point, because we are a web application. I mean, it's not like an application that has an always open channel to the server. Only when the user does something, or we have a time or something, we do request toward the server, I mean, the HTTP is a request response protocol. So only if the client initiates the communication, the server will reply with something. Otherwise, we are sort of isolated between the client and the server. Okay, so I already recommended to keep the fetch, and that is the fetch method, that is the method that allows us to communicate with the server in a separate JavaScript module, but just for convenience of programming. Okay, so everything is isolated and easily accessible from different parts of your application. And this is the architecture that we already saw on Monday. So there are the React component with the use state, with the useEffect, so we can write code that runs at specific points during the component life cycle. Mount time, when the components start to exist, as you did in the lab. Components is created, and you want to immediately start loading information. That's normal, okay? You rely on the API that calls the fetch. The fetch initiates the HTTP request toward the server. We have the Express server here with our routes, get, post. Initially the get, access the database, takes the data, and go back in JSON format, okay? And then fetch returns the promise. Remember that we ended the promise either with a return value, await return value, or .then and a callback. And then we use it typically to change a state. Because if we change the state, then React re-renders the application. So re-renders the view and the data is shown. Okay. We call this process rehydrating because it's a more generic, let's say, process than, I mean, just loading information. That means that we have a state on the client that needs to be synchronized with a state on the server, which is typically kept in a database because you want persistence on the server. Okay? And so there are two main operations that you need to do. So rehydrating means you don't have a state and you need to load some state, some parts of the state at least from the server. And the other operation, dehydrating, means extract, I mean literally the water, but actually extract the state, the new state that you need to store on the server, send it to the server and store it permanently on the server. Okay? This operation might happen several times during the React application execution. So it depends on what the user do. Actually, the users do, I mean, just do nothing, loads the page, you load the information from the server, nothing else happens. But then you start having the user interact with the application, and let's say it starts to add something, edit something, delete something, and so on. You have just a list of fields, but can be anything. It can be a form where you store, I mean, you register a new user and so on. I mean, you just create new entities on the server. Actually, first you create a new state on the client, okay, where you put the information, and then this state has to be synchronized. So you need to dehydrate the page and take the state and put it onto the server, okay? And get actually the updated state eventually from the server and put it back in the client, okay? Okay, so actually, I mean, ideally, every time we change something in the client, we should do the dehydrating operation. Means we should take the state that has changed and store it on the server. Actually, it depends a lot on the logic of the application. Okay, sometimes we just want to keep the, let's say, a temporary state on the client side, and only at a certain point store it, send it to the server. But typically, when the state becomes important in terms of size or what you need to store, I mean, you typically send it to the server because you want to have it stored permanently. Okay, not every time you type a letter in a form, but I mean, when you have finished entering something important, you want to have it stored on the server. Okay. Okay, so we already saw the rehydrating operation. Mount time is loading the state, the initial state from the server, and you experimented it in the lab. We also discussed about this waiting state, I mean, just to show something to the user while you're waiting for the response from the server. okay, so handling slow responses that I recall you, I mean, it might always happen in actual applications in the real world, because network connection is not always good, especially when you have wireless as well. And not only, I mean, the wired ones are typically more reactive and more reliable. Anyway, I mean, you should be prepared to the fact that network takes some time to transfer the information. Or maybe just the server, it takes some time to access the information in the database, retrieve all what you want and send it back to you. Okay? Okay. Now we have a problem in the sense that, I mean, we have the use effect and we can be triggered. I mean, our call can be triggered by the fact that something has changed. That is really easy. That's a list of dependency to put in the use effect. I mean, in principle, if you want to think in terms of use effect. But in general, our problem is not about what happens in the client, because there we can control what is happening. Is when things happen outside the client, on the server side. Actually, the so-called end clients problem. So actually, a typical web application is just run many times on many clients, the client part. The server part runs once on a single server. Okay, so the single server here with a single database and many clients, browser 1, 2, 3, 4. Okay, and so actually, all clients have their own state, and they want to read and write from the same server. Okay, so what happens in case one of the clients, so means here one of the browsers, updates some information that is also shown in another client, in another browser? But actually, well, I mean, it's a problem, right? You don't really know until you go to the server and ask for that information, okay? Because that's how the web works nowadays. I mean, this is a really important concept to understand. I mean, you are not just developing a normal standalone application on your PC, okay? This is not a normal, I mean, traditional application on your PC. It's a web application. It means that many can connect on the server, get their own copy of the client, and many clients are running in parallel, sending requests and getting information from one single server, okay? So don't think in terms of an application that you are the only one that is using the application. This is wrong. This is a traditional application. Like I do double click on something on the desktop and an application opens on the computer, okay, on the laptop. This is a traditional application. This is what we are talking about here. It's a web application. So anybody can access the page, open the page, then maybe it requires login, etc. We don't really care. We will see it later. But I mean, in principle, we can have many, many clients operating on the same server, okay? And so we need to handle these situations. So what happens in case someone else changed something on the server that we already loaded on a client? Actually, we have no solution to this problem, unfortunately, at the moment in this course, okay? Even at the end of the course, okay? So, I mean, that's how the web works. I mean, traditional web application with traditional web servers, only using HTTP, have no way of being notified of the fact that something has changed on the server. The only thing we can do, so this is the left solution, better than nothing solution. Sometimes we go to the server and we ask for an updated version of the information. Okay, we refresh the information. Here it says as frequently as possible. I would say, I mean, not every second you will overload the server. Okay, it doesn't make sense. But unless it's really required by some requirements in the text, in the logic of the application. But I mean, in general, when we do operations involving the server, if you are modifying something, this is a very good opportunity to get a new version of the information from the server. So just you want to update, delete, add some information in a list, just retrieve as a response the list of the updated information, okay? So you are synchronized with the server state as much as possible, okay? So this is actually not a real solution, it's just a way to minimize the problem, which it typically works, and if you design the application in a good way, it typically works well, okay? Think about the classical problem where you have single server, shared resources that you need to be able to use from book, for instance, from different clients. I mean, the usual example is the seats on the plane, train, the theater, and so on, okay? The server has the map with all the bookings, all booked seats and all free seats, and only the server has the updated copy. And you get a map on one client, you get the same map on another client, and so on. And then in the first one books a seat, okay? So it sends the information to the server. The server will book the seat, but the other clients still have the old map without a new booking, right? So, I mean, you need to just be able to handle the situation. You just need to know that operation that you send to the server can fail, okay? You see the seat is free. You book it. I mean, the server can say when you receive your request, it will say, okay, it's free. I'll book it for you. Or the answer can be, I'm sorry, somebody else has booked this seat. You cannot book this seat. And go back to the application. You show something, in some ways, you show the condition to the user. I mean, the updated state that you detected now on the server, and the user will do something else, okay? So it's like you book something and say, it's not available anymore, sorry, book something else, okay? It might happen. And I mean, it's not like your map, the seat map, gets automatically updated every time somebody is booking places on the server, right? I mean, actually, it's technically possible, but I mean, we are not going to cover this in the course, okay? Because, I mean, I just give you an example. You probably, all of you already use the applications like Google Docs, or what is Microsoft Office Docs online running in the browser. You type something and your friend sees what you are typing. I mean, you are being notified by the server of the fact that something new, and the state of the other client gets automatically updated, okay? That would be the nice and ideal condition, but we are not going to cover this because it requires much more effort, and I mean, it's not really just about the basic web application concepts, okay? Just you need to have some connection always open with the server, or a publish subscribe mechanism that basically means the same thing at a higher level, and so on, okay? So we need to handle this situation. And by the way, that is the way in which most of the applications work nowadays, okay? I mean, we want to book something in the plane. You don't typically get updates about in real time what is being booked, right? I mean, just send a request, hope that nobody else has booked the seat, right? And the server will tell you. If everything went fine, it will say, okay, otherwise, try again or something like this, okay? So just refresh the state when it's convenient to do, okay? So having said this, which I remind you is really, really important, you need always to think about the fact that there are multiple clients interacting with the server at the same time. This is a web application, not a desktop application. We will see how to solve, how to follow this pattern. And basically, every time we do some update, add, delete operation, second operation will be go to the server and get an updated state. Okay, so let's say in previous terms, rehydrate the application state. Okay, with the latest, the current version. Okay, so just a few more words about the useEffect that can be effectively used to do these operations. And then we will break. for 10 minutes, something like this. And then, as usual, we'll try to code something in our example. So try to implement a delete, add, and edit operations, okay, in this order, which is increasingly difficult. Okay? So before breaking, just a few more words about the useEffect. Well, you know, the useEffect is nice because now you have a tool that allows you to run code when something changes in the application, okay? So in principle, that's the tool you can use to run new requests toward the server when something changes. But it's a bit dangerous, okay? It's a very complex API, but also a bit dangerous sometimes because you need to be careful. If you use it in a wrong way, it might not work as you expect. Okay, two significant cases in which you might take things, have things working in the wrong way is, well, of course, you're missing the dependency array, so basically it runs at every render. So you defeated the purpose of the useEffect just by mistake. And one of the items in the dependency array, you would like it to be an object or an array. Okay, again, it's like with the state. I mean, it's a problem. So let's see the first example. First example, missing dependencies. Actually, what's wrong here? Well, actually, it's in the title, right? So, I mean, there's a counter that basically every time you click on the number, okay, on change, handle change, you do. I mean, this is on change, is just set the value in value, which is a controlled form, okay? And there's no button, nothing else, actually, because the code is wrong, okay? I mean, code is wrong in the sense that you see that every time you render this count input changes, okay, you will increase the counter by 1 because there's no dependency array, okay? So, I mean, you want to maybe count the number of characters, the number of times you changed this content here, type text, I mean, this box where you can type text. And actually, I mean, it's not really working as you expect because you should count the number of times the value changes, okay? Not just the value of times, number of times that the component is being rendered, okay, like it is here. By the way, this will create an infinite loop as well, okay? Why? Because every time you change a state, you re-render the component. And you re-render the component, you rerun the effect here, you change the state again, you re-render the component, and so on, okay? So you can just try this example. I don't have the code for this here in the computer, but I mean, it's something that might happen. I mean, here is really easy to see what is missing, right? So actually, you should have a dependency, okay? For instance, if you put a value as a dependency, it's fine, because every time the state changes, you change another state. But this is fine. I mean, you can change other states. Important thing is that you don't change the exact same state, because if the value keeps changing, you get into a loop, okay? You just update another state, it's fine, okay? So actually, the update of count depends on the change of value. So actually, we should put it in the dependency list in case it's needed. I mean, it's what we want, actually, okay? Here, something is needed because otherwise we go into this infinite loop. So be careful to set up dependencies in the correct way. I mean, with the correct list of things that you want to keep track of. Okay. So second example, count secrets. Okay. So we have an object which is the initialization of a state. I mean, a single state value, single for React, okay? So there's two properties in this object, value and count secrets, okay? And so the stuff is similar as before. I mean, there's an input type text, so a text box where you can type something. Secret.value is actually the value in the controlled form. And actually, on change, what we do is set secret, take the old object, spread the old object, and update the value, even target value. Okay? So you create a new object. New object that, and you return the new object. You see the round bracket here. It returns the value for the arrow function. Otherwise, it will be interpreted as start of a block of code. But like return this object, and you update the value. Okay, so this is fine in a certain sense, but you see that we have used the secret, that is actually the state, as the dependency of something that has been put here into the useEffect. So this code. Okay, if secret value equal to secret, do +1. Okay. So actually we wanted to say every time you type secret in the box, you do +1 in the count of secrets. Okay? But what's wrong here again? Well, actually here it's a bit more subtle. Because the point is that every time you create, you set, you call the onChange. So you do set secret, and you do this operation, you create a new object, okay? And this object is what is used as the dependency. And actually, how can React know if the object has changed or not? Well, actually, it does as we did for the states. I mean, it just checks if the reference is the same or not. If the reference has changed, that means, for React, that the value has changed. So it runs the code here, the callback of the useEffect. Okay? So, again, this is as before. I mean, we really don't want to run this code if actually nothing has changed. Okay? Actually, you see this here, set secret. It does the same as here, okay? But this is more dangerous because actually it creates a new object and it sets it on the same state that is being used as a dependency, like before, okay? No, sorry, not like, before, like this one, okay? C +1, okay? So it says something, well, this creates a re-render, and in this case, it just, trigger the execution of the code of the useEffect again. And if the value is secret, it just keeps triggering the execution of the code again and again, okay? Because actually, the content of the object is the same. No, actually, no, that's not. It doesn't matter. It's +1. Forget what he said. Okay, but I mean, the point is that the object is different, okay? So actually, you might have wanted maybe a dependency on the value, okay? If the value has changed, you want to check if the value is secret or not, okay? Not on the whole object, because the whole object creates a problem because you create a new object, okay? Of course, we could have written this update in a different way, okay? But if we write in a different way, so we don't create a new object, we have the useEffect that works, but the set state is not guaranteed to work anymore. I mean, in this simple example, it probably works. But you remember that we said, like with the arrays, every time you change something, create a new array. Here again, every time you change something in the object, create a new object. So, in principle, this is fine when you update the states. And this is actually what should be done. What is wrong here is using the object as a dependency. You should use, actual secret.value, a string as a dependency, not an object, not an array. So in short, how to solve these problems? Well, simply avoid using arrays and objects as dependency values in the useEffect, because the risk is having infinite loops, okay? Because if somebody updates the object, the array, and it keeps running the callback, and if the callback updates the object or the array, you create this infinite loop. And there's no way to exit from this infinite loop, okay? I think at a certain time, React stops executing the code, it prints something in the console, but basically your code stops the execution, so your application is not working anymore, okay? So that's not good, not for the exam as well. Okay, so in short, avoid arrays as dependency. The only safe array that you can use in the dependency is the empty array, okay? Well, actually, yeah, no dependency. Or, I mean, if you have arrays, just use some properties, maybe the length, if it's appropriate, okay? If the array doesn't change in terms of length, I mean, length does not work. But if it's about detecting a size change in the array, dot length could be an option. So the array dot length is something that you can use as dependency, okay? So it depends a lot on the on what you're going to do in the application, in the logic of the application, okay? So the message is, just be careful about these issues that might arise with the useEffect, okay? And I would say, given the time we break, I mean, we still have 1 hour and a half next week to finish the example, so we are not in a rush, but we start with fresh mind, and we will see how to send requests to the server to perform now this updates operation, I mean, in generic terms, so delete, update, and create, okay? So let's break for 10 minutes, and we will resume 2:40 more or less, okay? If there are no questions, as it seems.